Today we are going to expand upon our idea of multiplying with binomials and just consider some special cases that we look at. Just a couple situations that are a little bit unique, even though the process is the same. So the first option that we're going to talk about is multiplying binomials that are conjugates. Conjugates are when they look the same, but one has addition and one has subtraction. So when we look at these examples up here, right, this is an x, this is an x, this is an 8, this is an 8, but one's addition and one's subtraction, it is still two binomials. So we are still going to process or distribute, do that same double distributing process we did yesterday. So I'm going to take x times x, which gives me x squared. Take x times an 8, which gives me a positive 8x. And then I'm going to take negative 8 times x. That's a like term, so I'm going to write it underneath that other 8x. And a negative 8 times a positive 8, which gives me a negative 64. Okay, in this situation, when I go to combine like terms, a positive 8x and a negative 8x become 0. And so I don't need to write that down at all. And I'm just left with x squared minus 64. We look at our next one. Right, again, they're conjugates, so we're going to follow the same process. 4b times 4b is 16b squared. 4b times 7 is positive 28b. And then I'm going to distribute my second term, right, which is a negative 7. So negative 7 times 4b is a negative 28b. And negative 7 times positive 7 is a negative 49. Now we'll notice we have the same situation we had on the last problem, right? A positive 28 and a negative 28. These cancel and we're left with a 16b squared minus 49, right? So we'll notice when we multiply with conjugates, those two middle terms cancel each other out and we're only left with the first and the last term. Now, the other type of special case that we can look at is a binomial squared. And this is the one that my students miss the most. They really want to treat this like a power to a power and pass that exponent of 2 out. But we cannot do this when we have a binomial, parentheses squared. What we need to do is we need to rewrite it as a binomial being multiplied by itself, right? An exponent of 2 says to multiply whatever the base is, whatever's receiving the exponent, times itself. So this would really be a y minus 5 times a y minus 5. And once we write this, we then need to go through that full distributing process, right? So we'll say y times y is y squared. Y times negative 5 is negative 5y. Right? Then we're going to distribute the negative 5. Negative 5 times y is negative 5y. And negative 5 times negative 5 is a positive 25. And so we'll get y squared minus 10y plus 25. Right, so if we look at this next one, again, it's a binomial squared. So I'm writing this binomial times itself. And then I'm going through that full distributive process. So 3c times 3c is 9c squared. 3c times 9 is a 27c. 9 times 3c is a 27c, right? Those are like terms, so I'm stacking them. And 9 times 9 is 81. So now when I combine like terms, plus 54c plus 81 will be my final answer.